All right, so it's Mr. Vrandrick here to go over the review questions that you guys were working on this morning. And I'm going to go through 1, 2, and 3. I'm going to skip 4, 5, and 6 because those were you can do in the calculator very quickly. And then go through 7 through 14. All right, so let's start with 1, 2, and 3. So this was after looking online and talking with Miss Byrne that it's talking about using the geometric mean. So I'm going to show you the way that my brain has figured out how to do this, and then you can work with Miss Byrne on Thursday to make sure you understand for the test. Okay, so we're trying to find number 1, X, Y, and Z. So the first thing you want to look at is the altitude, which is that segment that connects kind of the bisector of this 90-degree angle to the other side length. So in this case, it is 4. So that 4 is equal to the square root of the two pieces of the hypotenuse for your biggest triangle. So in other words, that's 8 times x. All right, so let me do it again. 4 is equal to the square root of the product of those two pieces for the hypotenuse. All right, so if you solve for x here, we're going to square both sides. All right, so I'm going to square both sides. So 4 squared and square this. And what that's going to do is that's going to get rid of that radical to leave me with 16 equals 8 times x. So x is equal to 2. All right, so we've already found x. All right, now once I know that x is 2, I immediately realize that the hypotenuse then of that larger side is going to be 10, right? 8 plus 2 is 10. So the way that I solve for the y and the z is like this. So for y, I said y over, I'm going to set up a proportion. The first ratio in my proportion is y over the hypotenuse for the biggest one. So that's 10, y over 10. And then if you look at the piece of that hypotenuse that's closest to the y, that would be the 8. So that's going to be equal to 8 over y. When I was talking with Ms. Byrne, you guys kind of skip this step because you know that this is going to be the geometric mean again, all right? But I just want to show you that's where this comes from. So if you do cross products, y times y is y squared, and 8 times 10 is 80. So y equals the square root of 80. All right, so if you want to simplify that, all right, in that 80, all right, let's see, what's the highest one? I think it's just going to be 16. So the square root of 80 is going to be 4 times the square root of 5. All right, so that's y. For z, I'm going to do the same type of process. All right, so I'm going to put z over 10, because again, it's always going to start with the side length you're solving for, so z, over the hypotenuse, which is 10 of the biggest triangle, and then equal to the piece that's closest to z in the original problem was labeled x, but we know that x is now 2, so I'm going to put 2 over z. All right, so again, cross products, you get z squared equals 20, so z equals the square root of 20. So if you want to simplify that, it's going to be 2 times the square root of 5. So those are your three answers. X is 2, y is 4 times the square root of 5, and z is 2 times the square root of 5. So that's number 1. All right, and it looks like that example, all right, the way I would kind of think about it is in this number 1 example, it is telling you the altitude already. Okay, so it actually already has the altitude. Let's go to number 2. Now, number 2, all right, so number 2, they don't give you the altitude, but they do give you the entire hypotenuse with 12 and 6, right, of the biggest triangle, so it's 18. So when you do the geometric mean, you're going to have x equals the square root of 12 times 6. All right, so x equals the square root of 72. So if you simplify the square root of 72, you're going to find that that reduces to 6 times the square root of 2. All right, so that is going to be x. Now, when you solve for y, I'm going to set up those same ratios as before. We have y over 18, because that is the length of the entire hypotenuse there, 12 plus 6, is equal to the piece closest to y, which is 12 over y. All right, so if you do cross products, you get y squared equals 18 times 12, which is going to be 216. And so y is going to be the square root of 216. And that reduces to 6 times the square root of 6. All right, so there's y. Now for z, it's the same kind of idea. Z over 18 I know is going to be first because it's the entire hypotenuse there. And then the piece that's closest to z, if you look at the original figure, is that 6. So 6 over z. All right, so I'm going to set up that part of the proportion. And then do cross products. Get z squared equals 18 times 6, which is going to be 108. So z is equal to the square root of 108, all right, which reduces to 6 times the square root of 3. So this is going to be our answer here for z. So I have x, y, and z. Okay, now on this one, the way I would remember when I think about number 2 is number 2 did not give me the altitude, right? Like in number 1, they gave us the altitude was 4. So number 2, they did not give the altitude, but they gave us the entire hypotenuse, which allowed me to find it very quickly. All right, now number 3 is a little bit trickier. You're going to see a lot of the same work, but because they don't give you the altitude and they don't give you both pieces of that hypotenuse for the longest side, for the biggest triangle, we are not going to be able to start right away with the geometric mean. So what I'm going to do, and I'll kind of draw over it so you can see, is I'm going to use this idea that this triangle is a right triangle, all right, and I'm going to use Pythagorean theorem to find our letter y first, all right, because that letter y is the altitude, and that will allow me to find the rest of the pieces, okay? So if that's the case, then my hypotenuse for this triangle that I outlined in red is going to be 2 times the square root of 30, and I want to square that, all right, equals y squared, so I don't know y yet, plus 10 squared. All right, so 2 times the square root of 30 squared is 120, which equals y squared plus 100. So y squared is equal to 20. So y equals the square root of 20. So if you reduce the square root of 20, you get 2 times the square root of 5. All right? So that's going to be y, or the altitude here. Okay? So once I have the altitude, then this problem begins to look like number 1. So when I did number 1 with the altitude, I can set up the geometric mean for my altitude. So 2 times the square root of 5 equals the square root of x times 10. All right? So if I square both sides, so square both sides, then I'm going to have, that's going to be 4 times 5, which is 20, which we know we just finished coming from 20, equals x times 10. So x again is 2. All right, so far you'll notice I haven't really used any of those proportions like in the first 2 problems, but I will now to find z. So when I set up z, it's going to be z over 12 because the hypotenuse for the biggest triangle is 10 plus 2 now that I know that x is 2. So z over 12 equals, all right, and the piece closest to z is the x, which I know now is 2 over z. So when I do cross products, it's z squared is 24. So z equals the square root of 24, which when you simplify, you have that perfect square of 4 in there, is going to be 2 times the square root of 6. So those are my 3 answers for x, y, and z. Now, Ms. Burns said you'll need to know how to do one of the simpler ones. So I don't think number 3 I would characterize as one of the simpler ones because you had to use the Pythagorean theorem to start. But it might also, you could counter that it might be the simplest one because you had to do less proportions. But anyway, just take a look at 1, 2, and 3. All those are testing the same idea concepts, just in different processes. All right, so there's 1, 2, and 3. All right, let's keep going to number 7. All right, so you'll notice I'm skipping 4, 5, and 6 because we decided in class that if Ms. Byrne is going to give you a calculator, you can just type in the cosine of 60 degrees and get 1/2, the sine of 45 degrees and get the square root of 2 over 2, and the tangent of 60 degrees to get the square root of 3. All right, so number 7. Number 7 says to solve for PR. So I'm trying to solve for this piece right here. So I put a question mark. You can use X, whatever your favorite letter is. All right? So when I'm thinking about what I'm going to use to solve this, I notice they're giving me the angle Q. And so if I think about PR, that missing piece that I want to know, that is the opposite side from angle Q. They've also given me the hypotenuse, all right, since 4.5 meters is across from the right angle. So if I have the opposite side that I want to find, and I know the hypotenuse, then I'm going to use the trig ratio that corresponds to opposite and hypotenuse, so that is sine. So I'm going to do the sine of 18 degrees equals the opposite side. So I don't know. I'm going to use PR now. Equals PR over the hypotenuse of 4.5. Now, if Miss Byrne has taught you every time to use proportions, if you put that over 1, you get cross products. PR equals 4.5 times the sine of 18 degrees. So if you go to the calculator and type in 4.5 times the sine of 18 degrees, you'll get 1.39, and we're rounding here to the nearest hundredth, so 1.39 meters. All right, so that is the answer for number 7. Okay, number 8. Number 8 says to solve for AB. So I don't know what that one is, AB. Now again, using the same process we did for number 7, I have angle A, and they're giving me side length AC, which is the adjacent side to angle A. All right, so I know I'm going to be using some ratio with adjacent. And then I'm solving for the hypotenuse, because that's across from the 90-degree angle. All right, so this tells me I'm going to be using the trig ratio for adjacent over hypotenuse, which is the cosine. So the cosine of 51 degrees equals the adjacent, so 9, over, I don't know, AB. Okay? Make it into a proportion. Cross products, you get 9 equals AB times the cosine of 51 degrees. And if you divide both sides by the cosine of 51 degrees, you will find your answer for AB. All right, so in the calculator, I like to use the N over D button. I think it makes it a little bit simpler. So 9 over the cosine of 51 degrees. So that's going to be 14.30. All right, and the units here is centimeters. Okay, so that's number 8. Very similar process to number 7, using a different trig ratio. Let's do number 9. Now, number 9 says to solve for FG. All right, so for FG right there. Now, when I look at my angle that they give me, angle F, 34 degrees, that's the adjacent side. Oops, sorry about that. That's the adjacent side, ADJ. And then the side length GH is the opposite side length from angle F. All right, so that tells me I'm going to be using tangent, because tangent of any angle is the opposite over the adjacent side. So the tangent of 34 degrees equals the opposite side of 6.1 inches over FG. All right, so if I make my proportion again, I get 6.1 equals FG times the tangent of 34 degrees. You divide by the tangent of 34 degrees from both sides, you'll be left with FG. All right, use that N over D button again. It's 6.1 divided by the tangent of 34 degrees. And you get 9.04 inches. All right, so that's our answer for number 9. All right, so 7, 8, and 9 are some good practice problems to find those missing side lengths when you're using trig ratios. Now, 10 and 11 are actually very similar to these problems that you just solved, but you actually have to use the word problem in 10 and 11 to draw your sketch. So I went ahead in number 10 and drew the sketch based on this ramp that Nate has built. says it covers a horizontal distance of 10 feet, and it has the ramp rises a total of 3.5 feet. All right, so I put the height that it's risen is 3.5 feet. So it's asking for the angle that the ramp makes with the ground, which I labeled as theta. So if you're solving for theta, you'll notice you have the opposite side and the adjacent side in this triangle. So I'm going to use tangent again and get the tangent of theta equals 3.5 feet over 10 feet. So if I actually don't need to use my proportions here. We are saying that the ratio for this theta when you do tangent is 3.5 over 10. So in the calculator, I'm going to write the tangent to the negative first power of 3.5 over 10. All right, so do second tangent, and then n over d, 3.5 divided by 10. All right, and you get 19, and it says to doesn't round to the nearest degree. So 19.29 will round you to 19 degrees. So that's 19 degrees. All right, so that is our angle that the ramp makes with the ground, 19 degrees. Okay, let's go to number 11. Now, number 11, I drew this very, very simple drawing of this observer at the top of a skyscraper that's 910 feet tall. And they observe a tour bus, all right, and it gives us the angle of depression. And I know from talking with students in your class that when you do the angle of depression, it helps to make like another triangle or make what you would consider, almost like a square with dotted lines. And that angle of depression is 61 degrees. So to find this angle, which is ultimately what I want, you're going to do 90 degrees minus the 61 degrees. To get 29 degrees. So this is 29 degrees. All right, so if I'm trying to find the distance from the base of the skyscraper to the tour bus, which is here, I have the adjacent side for that angle, and I'm looking for the opposite side. So I'm going to do the tangent of 29 degrees equals, I don't know, over 910 feet. Okay, so if I do my proportion, I get my unknown, which I'm solving for, equals 910 times the tangent of 29 degrees. All right, so that's going to be equal to 910 times the tangent of 29 degrees is, we're rounding to the nearest hundredth, so 504. It says round to the nearest foot. Okay, so it's 504 feet is the answer. All right, so that's how far away the building is from the tour bus. Okay, let's go to number 12. Now, 12, 13, and 14 is when you guys are transitioning into using either the law of sines or the law of cosines. All right, so whenever I'm trying to do these problems, I'm hoping to try to do the law of sines if possible, and then kind of as a last resort, you'll see like we do in number 14, that when you don't have any angles, you must use the law of cosines. Okay, so in number 12, it's asking you to find angle B. So you're trying to find this theta here for angle B. All right, so let's try to do the law of sines. The sine of angle B, which I don't know, over the side length associated with angle B is going to be the one that's across from it, which is side AC, which is 4. So over 4 equals the sine of angle A, which I know is 85 degrees, over side length BC, which is across from that angle, which is letter A. So that's going to be 9. So if I use my cross products, I get 9 times the sine of B equals 4 times the sine of 85 degrees. All right, divide both sides by 9. You get the sine of B equals 4 times the sine of 85 degrees over 9. Now in the calculator, because you're solving for an angle and they're giving you a ratio, you're going to type in, all right, this is what I would type in, sine to the negative first power of 4 times the sine of 85 degrees over 9. If you type that in, that should give you the angle for angle B. All right, so we have second sine, n over d, 4 times the sine of 85 degrees over 9. Close it. You get 26, says to round to the nearest degree. Okay, so 26 degrees. All right, so angle B is 26 degrees. Okay, so you have to use the law of sines for number 12. Let's go to number 13. Now, number 13, all right, says to find RS. So we're trying to find this one here, okay? Now, when I look at that side length RS, it's across from angle T. So I'm going to label it as T, all right? They've also given me angle S, and they've also given me side length S. So I'm going to try to do the law of sines here. So let's do the sine of T, which is 108 degrees, over T, which I don't know, equals the sine of 35 degrees over the length across from it, which is 11. So I can solve for my T, my unknown. That's side length RS. All right, so cross products, 11 times the sine of 108 degrees equals T times the sine of 35 degrees. Divide both sides by the sine of 35 degrees, and you will have T. All right, so in the calculator, use n over d, 11 times the sine of 108 degrees over the sine of 35 degrees. So I got 18, it says around the length of the nearest 10. So 18.2, doesn't give any units, so 18.2 units. So side length RS is 18.2 units. All right. Okay, number 14. Now, number 14, all right, it's asking for angle M. All right, so if I label my side lengths, this would be lowercase m for that side length, lowercase n, and lowercase l. All right, now you'll notice here we don't have any angles. So the moment I see that we don't have any angles, I know we must use the law of cosines. Now, because I'm solving for angle m, I'm going to write down my formula as m squared to start with. All right, because I know I'm going to have angle m in this formula if I start it with m squared for the side length. So that's going to be equal to L squared plus n squared minus 2ln times the cosine of m. Okay? So if I plug in my numbers, that's 7 squared equals 15 squared. Be consistent here. 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of m. Okay? So that's going to be 49 equals 225 plus 100 is 325 minus, and this is going to be 300 cosine of m. All right, if you move that 325 over with subtraction, all right, you're going to get 49 minus 325, which is negative 276, equals negative 300 times the cosine of m. Divide both sides by negative 300. You'll notice a negative divided by a negative becomes a positive. And you are more than welcome to reduce that fraction. In the calculator, I'm just going to type in the cosine to the negative first power of that fraction. And that will give me angle m. All right, so second cosine n over d, 276 over 300. Close it and get to the nearest degree for this angle is 23 degrees. So the answer for angle m is 23 degrees. All right, guys, so that's all the problems here for 1 through 14. As I said, Ms. Burns said, don't worry about the vectors for 15 through 20. All right, so hopefully you'll be able to review this before Thursday and then talk with Ms. Burns about any questions you still have, and good luck on your test on Thursday.